Hello everyone, my name is Christopher Bernardo, and I worked alongside Alan Howe, Gustavo Elizalde, and Dominic Torres, and we are Fire HUD. Our project is a heads-up display that will help firemen during their duty. Our target audience will be the government or contractors that work with firefighters. Our heads-up display will be giving data such as location of their peers, the CO levels, and the temperature, and also their own heart rate.
Our project consists of the main important components, which is the temperature sensor, the CO sensor, the GPS, and the heart rate. For the main microcontroller we're using, it's the Arduino Uno. Since it operates at low power, the MQ7, which is the carbon monoxide sensor, the TMP35, our temperature sensor, and its range goes from -40 to 125 Celsius, and its accuracy is ±1 degree. The GPS, it's the GTU7. It operates from 3.6 to 5 volts. And for the GPS, we needed to use a source code named Tiny GPS++. The heart rate monitor, it's the gravity heart. It uses an optical technique that detects the changes of the blood volumes. For our display, we're using the LCD display module, and its dimensions are 69.5 by 14.5 millimeters. Now, the timeline of our project. We started by creating a bill of materials that will allow us to purchase the most optimal materials for us. Selecting the components and doing quality control took us about 2 weeks, and we had some delay due to the shipping of each components. The assembly of the project, we wanted to place the components on the most optimal place for them to have the best readings. So that took us to week 3. Since we all wanted to, the next portion of the project was the hardest part, since it was the coding and understanding what we wanted the code to do. This part took us about 4 weeks. The coding extended to troubleshooting the code and testing each component to make sure it worked as we wanted it to work. And now it's leading us to the final weeks of the semester, where we have to finalize the project and do another quality control for code and the product.
So for the management style, what we had was a leader, which oversees everything. He talks to an operating manager that makes sure that whatever that needs to get done is conveyed to the other workers. As you could see from uh, this this picture, everyone's interconnected with the software developer because we wanted to make sure that whatever we wanted to implement, that the software people are able to actually physically do it. And same with vice versa. If they want to implement something, can our hardware function? So overall, we had strong communication with each other. There was nothing that was lost in communication because we made sure that we followed this management style to communicate, to to build our project, our fire HUD, and to make sure that we implement the most that we could with the time given. So now we're gonna start demoing our project with the GPS first. As you can see from the GPS, it reads the latitude and longitude. and it'll give you the X and Y coordinates while and it'll store that data. Now we're going to show the temperature sensor. As you can see, it is reading around room temperature, 31, and as Gus lights it, over time, it'll start going up. 30, 30, 24, 41, 42. As you can see, it's going up. And then we set, because we wanted, since our helmet was had a low threshold, we had to set the temperature for this live demo to be giving a warning level at 41, but we do want it to be warning level at 100 plus. Okay, so next demo we're going to show is the BPM for our CO sensor. As you can see, 5 is normal usually, and then once it starts getting 50 and 60, that's when it starts getting dangerous. And as you can see, it shows a warning sign when it reaches above that threshold. And then the last thing we're going to show is the BPM of the heart rate. We had issue near the end of our presentation. I mean, due to because of our sensor was broken and we didn't have time to source another one. But this was from our previous demo that we had when we presented it to the professor. Okay, so I'm gonna quickly go back and we're gonna talk about each what we demoed and a little bit detailed of it. So the GPS, this is the diagram for the software algorithm. So the GPS, what we do is we use a library from that we took online because we couldn't program that ourselves. We didn't know how to parse the GPS data, so we needed to use a library online library that someone else did. But once we were able to parse the data and then be able to read the longitude and latitude data. And then, so what's going to happen is Arduino is going to read from the NMEA data, and then which contains all the information that you need from longitude data, latitude, time, date. Yeah, I think these are basic things that the GPS data sends. And then what we're going to do is we're going to store it, and at the same time, we're going to print out the X and Y coordinate that you see. So for a temperature sensor, the Arduino, how it works is the Arduino will read since our temperature sensor is analog, what it's going to do, it's going to read the analog voltage. It's going to convert that analog voltage into to temperature based on the analog, based on the data sheet. And then what's going to happen is we're going to have it measure what temperature it is. So if it reaches past a certain threshold, then it's going to give a warning in the LED, which you saw in the serial port. It was displaying a warning when it passed a certain temperature. Next, the carbon monoxide. It's the same thing, similar to the temperature sensor. What's happened is it's going to read the digital out from the sensor, and what's going to do is convert its ppm it's going to convert it into ppm, and we're going to read it. And if it's high, which in our case you don't want anything higher than 60, then you want to give a warning on the LED screen. And lastly, the heart rate monitor. It has a readout signal, and what it does is we're going to convert that pulse to a BPM based on its PWM, and then it's gonna do two things. It's gonna blink based on your BPM, and also it's gonna print out what your BPM value is on the LED screen. And then that's it. And then next part, oh, and who's responsible for each part? So Chris and Dom completed the temperature sensor. Me, Chris, and Gustavo made sure that the heart rate monitor was working. Me and Gustavo also completed the CO sensor, and then the GPS required the whole group to work together because we needed to really understand the source code, or at least the library code, so we could use its function. And then and then we're gonna now talk about the challenges.
I think one of the biggest issues we faced during our project was due to COVID and the limitations and restrictions we had to follow for our safety because of it. Because of COVID, we were not able to meet as often as we had originally planned, which affected our construction time and design. When we began to buy our components, many of them were not available, so we needed to change our original design. And the parts we did order actually got delayed a couple of times. Additionally, the price of many of the components we wanted to buy increased, and we slowly went over our budget. Because of these challenges, we learned that R&D is not an easy task due to COVID, time, and money. Even though we planned everything ahead of time and tried to plan for issues, things still didn't turn out the way we liked. Overall, we also realized the importance of physically meeting up when working on a project together. We couldn't share many of the tools and other materials that would help speed up the R&D process and time. Also, it didn't help that we all lived in different cities and couldn't easily drop things off or work on many of the physical components. Because of these issues and things didn't turn out the way we liked, these are our future plans for Fire HUD. The temperature sensor we used in the project can only read up to 125 degrees Celsius, but during a wildfire, that temperature can easily be exceeded. So we plan on using thermocouples to read and display higher temperatures. We also plan to incorporate wireless communication and transmit data to a central hub via a drone. Additionally, the drone will have an anemometer attached to record wind speed and wind direction and relay that information to the firefighters.
So this concludes our presentation for our project, our Fire HUD project. Again, I'm Alan, and then my other group members are Chris, Gustavo, and Dominique. And thank you for taking your time to listening to our project. Have a good day.